A supermassive black hole found spitting a giant high-energy jet towards our Earth. Space.com Robert Lee reports, NASA has identified a supermassive black hole blasting its energetic jet towards our Earth. Don't worry though, they said, the blazar is located 400 million light years away. A NASA mission has observed a supermassive black hole pointing its highly energetic jet straight towards Earth. They said, don't panic though, as fearsome as this cosmic event is, it's located at a very safe distance of about 400 million light years away from us. Actively feeding supermassive black holes, including the one at hand, are surrounded by swirling disks of matter called accretion disks, which gradually feed them over time. Some of the matter they don't swallow is then cancelled and channeled out towards their poles, where it's subsequently blasted out at near light or relativistic speed. This creates highly energetic and extremely bright electromagnetic radiation. In some cases, like with NASA's latest MUSE, that jet is pointed straight towards our Earth, and those events are known as blazars. This blazar, designated Markarian 421 and located in the constellation Ursa Major, was observed with NASA's Imaging X-ray Polymetry Explorer IXPE, which launched December 2021. IXPE observes a property of magnetic fields called polarization, which refers to the field's orientation. The polarization of the jet blasted out by Markarian 421 revealed a surprise for astronomers, showing that the part of the jet where particles are being accelerated is also home to a magnetic field with a helical structure. Blazar jets can stretch across space for millions of light years, but the mechanisms that launch them are not well understood yet. However, these new discoveries surrounding the jet of Markarian 421 could shed some light on this extreme cosmic phenomenon. Markarian 421 is an old friend for the high-energy astronomers. Lead researcher behind the discovery and Italian Space Agency astrophysicist Gloria Di Gessa said, We were sure blazar would be a worthwhile target for IXPE, but its discoveries were beyond our best expectations, successfully demonstrating how X-ray polymetry enriches our ability to probe the complex magnetic field geometry and particle acceleration in different regions of relativistic jets. And the twisted structure of blazar jets. The main reason jets of feeding supermassive black holes are so bright is that particles approaching the speed of light give off tremendous amounts of energy and behave according to the physics of Einstein's theory of special relativity. Blazar jets also get an extra boost to such brightness because their orientation towards us causes wavelengths of light associated with their jets to bunch up, increasing both their frequencies and energies. This is similar to how sound waves from the siren of an approaching ambulance bunch up to cause an increase in frequency that makes it sound more high-pitched. As a result of these two effects, blazars can often outshine the combined light of every star in the galaxies that house them, and now IXPE has used that light to paint a picture of the physics going on at the heart of Markarian 421's jet, and even identify the glowing beam's point of origin. Previously, models of blazar jets had hinted that they're accompanied by helical magnetic fields, almost like DNA in living cells, except single rather than double-stranded. And what was not predicted, however, was the fact that the magnetic helix would host areas where particles are being accelerated. We had anticipated that the polarization direction might change, but we thought large rotations would be rare based on previous optical observations of many blazars, research co-author and Massachusetts Institute of Technology physicist Herman Marshall said. So we planned several observations of the blazar, with the first showing a constant polarization of 15%. Even more remarkably, analysis of IXP data showed that the polarization of the jet dropped to 0% between its first and second observations, and this showed the team the magnetic field was turning like a corkscrew. We recognized that the polarization was actually about the same, but its direction literally pulled a U-turn, rotating nearly 180 degrees in 2 days, Marshall said. It then surprised us again during the third observation, which started a day later, to observe the direction of polarization continuing to rotate at the same rate. During these maneuvers, measurements of electromagnetic radiation in the form of optical, infrared, and radio light showed no effect on the stability and structure of the jet itself, even when X-ray emissions did change. This implied a shock wave traveling along the twisted magnetic field from Markarian 421. Hints of such a phenomenon have once been seen in the jet of another blazar, witnessed by IXPE Markarian 501, but the team's new findings represent more clear-cut evidence that a helical magnetic field does indeed contribute to a traveling shock wave that's accelerating jet particles to relativistic speeds. The team behind the work intends to continue studying Markarian 421, as well as identify other blazars to find some with similar qualities in pursuit of revealing a mechanism that powers the extreme and bright outflow characteristics of these phenomena. Thanks to IXPE, it's an exciting time for studies of astrophysical jets, Gesu concluded. The team's research was published on Monday, July 17, on the journal Nature Astronomy, and this was originally posted on space.com. And this is on Live Science by Robert Lee. Please leave your comments, and thank you for your support. My Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.